if they gave the weather report and they said it's going to be such and such Celsius out today, you wouldn't know whether to grab your winter coat probably or your swimsuit and head for Galveston. And so we got to be able to switch back and forth. And I'm not going to derive the equation. Just here it is. You can kind of see where this is coming from. Okay, first of all, you've got two variables here. Fahrenheit, Celsius. Need to know. Now, there are other renditions of this thing out. Sometimes you see this 1.8 as a fraction, 9 over 5. I don't like that because that makes me punch two things in my calculator. I prefer this form. Also, you could rearrange this algebraically and solve for C. I just remember it this way. Then in a problem, if they give me Celsius, I plug the Celsius in right here, do the math, and get Fahrenheit. If they give me Fahrenheit, I put the Fahrenheit over here, then do some algebraic rearrangement and solve for the C. Yeah.
Is that 1.8 times C?
Yes. Yeah. 1.8 times whatever it is in Celsius. Good clarification. Okay, now let's think a little bit about where those numbers come from. If I take the difference from here to here, how much is that? What's the difference?
180.
180. Okay, that's a 180, whoops, I don't want to put that. 180 Fahrenheit degrees difference. Whereas this is only 100. Hence the 1.8. 180 over 100. Okay, 32. Well, hey, this guy got a head start. Okay, so that's going to be plus 32. So that's where they come from, although you can, in the book, they have this nice long derivation. I used to do it in the past, but my students, their eyes would roll back in their heads, and I thought, what's the use? Just say, here's the goods. This is what we need. So, we also, though, have a third one that we use, and it's the Kelvin. And that's abbreviated with a capital K. And by convention, they don't put the little degree sign there as they do with Celsius and Fahrenheit. Kelvin is sometimes referred to as the absolute scale. What they did is, what's the lowest temperature possible? And this is in theory. The lowest temperature possible is minus 273 Celsius. At that temperature, if you ever arrived at that temperature, minus 273, all molecular or atomic motion would cease. And so if that's the lowest temperature you can go to, let's call that 0, and we get to trash negative numbers. And so this is going to be 0 Kelvin. Now I'm going to come over here. This would be minus 273 degrees Celsius. The lowest temperature you can arrive at.
That's absolute zero.
That's absolute 0. So somebody goes, hey, let's just make a new thing. Let's set that at 0, and then we don't have to screw around with all these negative numbers. Okay, so they set that at 0, but they were clever enough to keep the size of the degree the same, and so 0, when water freezes, is 273, and then where it boils will be 373 Kelvin. And so a second equation we need to know, Kelvin is simply equal to whatever Celsius is plus 273. Now in your book, they put that as 273.15 and they use 5.6. That's overkill. Don't clutter up your brain with that extra. So just 273. So there's two more good candidates for flashcards. Need to know. Now, let me ask you a question. Let's say you have a fever, and the more fever you have, the sicker you are. Okay, are you sicker with 1 degree Celsius fever or 1 degree Fahrenheit fever? Which are you sicker? 1 degree Celsius. Why?
Because they're bigger increments?
Yeah, there's a bigger difference between 1 and 2, or whatever it is in Celsius, because Fahrenheit's divided up for the same difference 180 ways, whereas Celsius is only divided up 100 ways. So a Celsius degree is a bigger degree. Okay, now, let me make up a couple of problems here to make it realistic. You are in some other country and you get sick. This really happened to me in Paris one time, years and years ago. I got really sick and the doctor came to the hotel room, took my temperature, and said, "You got a temperature of 37. And I thought, oh my God, I'm going to die. But I was in another country. So let's say this guy told me I've got a temperature of 37.0 degrees Celsius, but because maybe in chemistry I think Celsius, in everyday life I'm just like you, I think Fahrenheit. And I'm talking about body temperatures and stuff. So here's your problem. I want to get that translated so I will understand if I've got a fever or not. So we look at this, and most of these are pretty clear cut. You see the C, you see the F, what that should trigger. There's your big clue. It's a temperature conversion. That should trigger this equation. And there's two variables, they got to give you one. And then you solve for the other. So we have degrees Fahrenheit, 1.8, and Andrew, this will show you the question you asked a second ago. Let's assume this is an absolute number, so this is what's going to dictate our 6.
The 37.2,
Yeah.
because 1.8 is always,
Let's just say that's absolute. See, it's 180 exactly over 100 exactly. There's no doubt. I haven't done any rounding. You know, it's similar to when I'm counting people in the row. There's 4 in this row. I have no doubt about that. Okay, so we want to multiply this out, then add it onto here. Then don't think about rounding until you finish up. Now, some people do this, and I think it's a really bad idea. They do this, round it to the appropriate sig figs, and then go on. No, don't do that. Just keep everything rolling until the tail end. So let's do this. Tanya, do you have that punched?
66.6.
How much?
66.6.
66.6?
I got 98.
I
Oh, total?
God, I would be dead.
No, you worked it
Oh,
out.
okay, I meant the whole.
It's 66.6 plus 32, and that's 98.6.
98.6 degrees Fahrenheit, which is accepted as normal body temperature. So I wasn't running a fever. I may have been sick other ways, but I wasn't running a fever. Andrew?
so the 37.0 degrees Celsius, that will determine how much degrees you have?
Yeah. Usually, as a rough rule, whatever makes the problem unique, you know, what makes it a different problem than every other problem, it's that 37.036, go for it.
Okay.
So I have 3 in your
Guessing
answer.
it's
Yeah. And in the conversion factors and everything, just assume that they are whole numbers with an infinite number of sig figs. Now, somebody else had a question on temperature? Yeah, Trent.
Wouldn't it be 99 if we put that?
Okay, but how many, let's go back here. How many sigs? 3.
But then you're adding legislation.
Okay, but if this is, that's a good point, tricky point. She's an attorney in training. When you're adding this, and it has no decimal points, yeah. But let's just say 3, okay? All right, so let's go for 3 because I wanted you to see it's exactly what we memorized as normal body temperature.